Hello, welcome to the third part of the 100 likely mathematics UTME questions for the year 2026. If you haven't seen the previous videos, endeavor to do that immediately, because in those videos we treated questions on arithmetic progression, logarithm, indices, change of subject, integration, and so on and so forth. So it's very important that you do that so that you can be aware of so many things that we discussed in those videos. In our first question, we are told that the binary operation direct sum on the set of real numbers is defined by x direct sum y equals x plus y over 2, comma, for two real numbers x and y, find the value of 1 direct sum minus 3 over 2. So you can be given questions on binary operations, but it's not that difficult. All you just need to do is, wherever you see the operation, this operation that we are given, because it might not be direct sum, it can be operation star, it can be anything. So whenever we are given this operation, you just impute and replicate what you have here inside this particular expression. So if I have x direct sum y is equals x plus y over 2, then if I want to solve 1 direct sum minus 3 over 2, that means that wherever I see x, I'm imputing 1, then wherever I see y, I'm imputing minus 3 over 2. So that gives me 1 plus, what is my value for y? Y is minus 3 over 2, minus 3 over 2, all over 2. So that being said, this can be reduced to 1 minus 3 over 2 over 2. Now I want to quickly tell you something on how you can do this without solving. So whenever they ask you to do 1 minus a fraction, for example, if you are told to do 1 minus 9 over 11, the answer is 2 over 11. How do I know? I know that if I find the LCM will be 11. The LCM will be 11. If I put this over 1, 2 in 11 is 11. 11 times 1 is 11. 11 minus 11 in 11 is what? 1. 1 multiplied by 9 is 9. And what I would have is 2 over 11. How did I know? So the point is, if you have 1 minus a fraction, just deduct the numerator from the denominator, then you have your answer. So as 2 over 11. So that means that the answer to this, what would that be? The answer to this is what? Minus 1 over 2. Then over 2. So the continuation to this gives us what? Minus 1 over 2, that's times 1 over 2. Because if I do divided by, then I'm going to change the multiplication, then it becomes 1 over 2 on the end. So my final answer to this is minus 1 over 4. Number 22. We are told that the midpoint of point x and point y is this. Now look at this. For point x, we are not given the values of the x and y, but for point y we are given, and so we are given the midpoints. So it's as though that they gave us the answer and they are asking us to find the elements, the points that formed the midpoints. So what do? Let's first write out our formula. Then we have x comma y, which is the midpoint formula, is equals to, open a bracket, x1 plus x2 over 2, comma, what would y1 plus y2 over 2, then I close this. This is the midpoint formula. So we are told that the midpoint itself is what? 4 comma minus 1. Then is equal, what's my x1 now? If I put the points x1, y1, what about here? x2, y2. So our x1 in points x is a, then our x2, what's our x2? Our x2 is what? 2 over 2, comma, y1 is what? Y1 is b, then y2 is what? 7 over 2. Now, when we get here, what we do is you equate this 4 to this first point here, because this is point x, this is point x, this is point y, this is point y. So I would have that a plus 2 over 2 is equals to 4, because they are equal to each other. Then I have b plus 7 over 2 is equal minus 1. So if we cross multiply, we would have a plus 2 equals to 4, then we have, equals to 8, then we have a equals to 8 minus 2, a is equals to 6. Then for point b is equals to minus, b plus 7 is equals to minus 2, because if we cross multiply, then we'll have that b is equals to minus 2 minus 7, all that gives us minus 9. So the value for a is 6, the value for b is minus 9. If alpha and beta are the roots of the equation 3x squared minus 5x plus 2 equals to 0, find 1 over alpha plus 1 over beta. This question is under sum and product of roots. So how do we solve it? So you need to remember two things. First, that alpha plus beta equals to minus b over a, then alpha beta equals to c over a. It's very, very important. So looking at this that we are asked to find, I have 1 over alpha plus 1 over beta. I have to look for a way to simplify this so that it will either have this, or even maybe both. So what I can think of is the LCM of both denominators. So LCM is what? Alpha, beta. Alpha will cancel alpha. What we have left is beta. Beta times 1 is what? Beta plus Beta cancels beta. What I have left is alpha. Alpha times 1 is what? Alpha. Now it's looking like it, right? If I write alpha first before beta, then you notice that these two terms are already there. So what I need to first find is alpha plus beta. Now from here, alpha plus beta is minus b over a. So I need to know what b is, and I need to know what a is. So if I look at my quadratic equation, 3x squared minus 5x plus 2 equals to 0. If I compare with the general quadratic equation, which is ax squared plus bx plus c equals to 0, my a is 3, my b is what? Minus 5, because the coefficient of x is minus 5, then our c is 2. So alpha plus beta, which is minus b over a, will give us what? Minus, what's our b? Minus 5 over a. A is what? 3. This here will give us what? Plus 5 over 3. Then alpha beta is c over a. So our c in this place is what? 2 over a, and our a is 3. So let's finish up. So alpha plus beta, 5 over 3. Alpha beta, 2 over 3. So we need to simplify this. 5 over 3 divided by 2 over 3. If we change the division to multiplication, we have 5 over 3 times 3 over 2. Then our answer is what? 5 over 2. For our next question, we are asked to simplify this logarithm question. Now, if you observe properly, the bases there are not common at the moment, because the first base is 1 over 8, second base is 2, then our third base is root 2. So what we could do is try to simplify and manipulate so that their bases can be common, and see if you can work with it. So I noticed that I have 1 over 8 here, I have 2 here, I have 2 here. So it's possible for me to simplify it. But I need to first introduce one very, very important rule. And that rule is, if I have log, let's use a variable, log m base n, then the base is carrying a power, let's say power of y. If I have a scenario like this, I can rewrite this to become the reciprocal of that power, then it becomes a coefficient, then I write log m base n. I'll give you an example. If I have log 4 base 8 and I'm asked to solve this question, so the best thing for me to do is simplify this base, because the base is too big. So what I can do is, I have log 4, this 8 can be written as 2 raised to the power 3, I believe you agree. Then if I take the power from the base, not from the top one is different. If you are taking it from the top, it's not going to be reciprocal, but if you are taking it from the base, it's going to be reciprocal. So if I take it here, I would have 1 over 3 log 4 base 2. So to finally finish up this question, that will give us what? Log. This 4 can write as 2 raised to the power of 2 base 2, right? Now, if I now take it from here, it will just be ordinary multiplication. So that's 2 times 1 over 3, give me what? 2 over 3 log 2 base 2. Then log 2 base 2 is 1. Then 1 times 2 over 3 is 2 over 3 as the answer to this particular question. So this is very, very important. Now, we would have log 64. 1 over 8. Let's simplify 1 over 8. So if we have 1 over 8, I know that this is 8 raised to the power of minus 1. Then I know that this 8 is 2 raised to the power of 3, and I still have minus 1, which was the initial power. So if I open it, I'll have 2 raised to the power of minus 3. So what we have here is 2 raised to the power of minus 3. Then next one is plus log. Now this is a sort, and we need to simplify it because there is a perfect square inside. So if I have questions like root 48, I need to look for the highest perfect square that will divide that number, and it must be the perfect square multiplied by a prime number. So what I would have is, I thought about several perfect squares. So the highest of them is 16 that can divide 48. That's 16 times 3, I believe. So if I simplify that, I'm going to have root 16 times root 3. Root 16 is, square root of 16 is 4. Then what I would have is 4 root 3 as the answer to root 48. So I'll introduce that for root 3 here. 4 root 3 base 2. Then I would have minus log 4th root. This is not 4 root 3, this is 4th root of 3, because it's inside the roots. But this one is 4 root 3. So this denominator base here, that root 2, I can write it as what? 2 raised to the power of what? 1 over 2. So 2 raised to the power of 1 over 2. Now it's looking like we are arriving at our destination because we have 2, 2, 2. But next thing that we need to do is we need to take the power away, like I explained using that rule. So if I take the power here to become a coefficient, then it becomes a reciprocal. So the minus here, let me put it up, then it becomes a reciprocal of the number, that's 3. Then log 64 base 2 plus log 4 root 3. This 2 is okay here. Minus, but for this is a fraction. If I'm finding the reciprocal of the fraction, it will swap. The denominator will go up. That was 2 log 4th root of 3 base 2. Is that okay? So before we can pick one log to the base of 2 that is common, we need to first remove this coefficient. So if I return this here, I would have log 64 raised to the power of minus 1 over 3 base 2 plus log 4 root 3 base 2 minus 2 log, minus log 4th root of 3 raised to the power of 2 because it's going to become a power here. If you are returning it, it's going to become a power. Then this has base 2. So from here, we can pick one log to the base of 2. Now let's simplify. This that I have here, 64 raised to the power of minus 1 over 3. If I remove the negative sign, I'm going to have 1 over. Then the 1 over 3, that is the fraction. So the denominator of the fraction will form the root, while the numerator will form the power from indices rule. That is fractional index, rule of fractional index. So the denominator will be cube root of 64 raised to the power of 1. Now cube root of 64 means one number you multiply 3 times, that will give you 64, and the number is 4. So the answer to this question is 1 over 4. So we'll have 1 over 4 plus will give us times. That's times this value that we have here, times 4 root 3. Is that okay? Then this minus becomes divided by what? The answer to this. So what's the answer to that? 4th root of 3 all raised to the power of 2. Now to simplify this, the power here is 2, the power here is 4. Remember that the roots, if the value here is coming from the denominator, and this one is the numerator. So if I rewrite it, I'll have 3 raised to the power of 2 over 4. Then this will give me 2 here 1, 2 here 2. I'll have 3 raised to the power of 1 over 2. So 3 raised to the power of 1 over 2 is root 3. So finishing up, we'll have that divided by root 3. Now we'll have log 2, 1 over 4 times 4 root 3 times 1 over root 3. If we change division sign to multiplication, now what can cut? Root 3 will cancel root 3, obviously. 4 will cancel 4, obviously. What have we left it? I believe 1 times 1 times 1 will give us what? 1. Now we have log 1 base 2. Now we can't stop it. This cannot be our final answer because we can rewrite this 1 as our base, which is give us what? 1 can be rewritten as 2 raised to the power of something, and that will be what? 2 raised to the power of 0. So 2 raised to the power of 0. If I take this 0 to become a coefficient, I have 0 log 2 base 2. Then I'll get 0 times log 2 base 2 is 1. Then the answer to this question is 0. We are asked to find the area of a solid cylinder of height 6 cm and diameter 14 cm, and there is a clause. You must solve in terms of pi. That means that you will be introducing the value of pi, that is times 2 over 7. So how do we do that? Now, you can be asked to find the cost of area of a cylinder. You can be asked to find the area of a cylinder when it is closed at one end, and so on and so forth. So you have to know the individual formulas for all of this. But for this particular question, this is a solid cylinder, meaning that it is closed at both ends. So let's quickly introduce the formula. So the total surface area of a cylinder that is closed at both ends will give us what? 2 pi r squared plus 2 pi r h. If we factorize this, we have 2 pi r will give us what? R plus h. So this is the formula that we are using. So we'll have that our height is 6 centimeter. Then since diameter is 14 centimeter, I believe you can guess what the radius will be. The radius will be what? 7 centimeter, because half of the diameter is the radius. So we'll have 2 pi times, what's our radius? What's our radius? Our radius is 7. Then we'll have 7 plus 6. That is our height. So finishing up, we have 2 times 7, 14 pi. Then 7 plus 6 is 13. So we have to do 14 times 13. 14 times 13 will give us 12, 4, 4, 1, 182. So 182 pi centimeter square will be the total surface area of the solid cylinder. We are given this differential question for our number 26. If y is equals 5x squared cos x, find the square y dx squared. How do we go about it? So we are asked to differentiate it twice. But if you consider this, you must check your question properly, because that will determine if you are solving it using chain rule, that is function of a function, or you do it using product rule or quotient rule. So for this now, if we check it, we have y equals to 5x cos x. So if I compare the functions, I have an ordinary function here, then I have a trigonometric function here. So, and they are both multiplying themselves. So that basically tells me that I'm using my product rule formula, where u is equals to this 5x squared, and then my v is equals to cos x. So remember that the formula for product rule is given by what? Dy dx will give us what? U dv dx plus v du dx. So then I need to differentiate my u now. If I differentiate my u with respect to dx, I'm going to get 10x, because 2 times 5 is 10, If I deduct 1 from it, I'll get 10x. Then next one is dv dx. dv dx will give me, when I differentiate cos x, I'll have minus sine x. Minus sine x. So imputing all of this in the formula, we would have dy over dx will give us what? U. Our u from the question is 5x squared. 5x squared. dv dx is minus sine x. So put the minus at the front, then put the sine x at the back. Then plus our v. What's our v? Cos x, and our du dx 10x. So 10x will be at the front. The trig function will be at the back. So we have cos x, 10x cos x. So the goal is that we have to repeat this one more time because we are asked to find d square y dx square. All right, so we need to do it one more time. So the same process that we followed, but this time around we need not to write the formula because that will take our time. So we can actually do it one more time. So d square y dx square, that's what we want to do now. So I know that this is also another product. This is also another product. So it might look big, but it's actually simple. So imagine this is your u, imagine this is your v. So if you differentiate, because your formula is u dv dx plus v du dx. So this is our u, you're writing u first, minus 5x squared dv dx. What's dv dx? You have to differentiate sin x, and that'll give us what? Cos x. Plus v, the v is sin x, du dx. So du dx will be minus 10x, because if you differentiate this, you get minus 10x. So instead of me writing plus here, I'll have minus 10x. I've just differentiated this part. Then I do the same thing with this. The formula is u dv dx plus v du dx. So our u is still 10x. U dv dx, this is the v. So dv dx will be the derivative of cos x, and that will be minus sine x. So the minus, I introduce it at the front here, minus sine x. Then plus v du dx. V du dx, for by differentiate this will be 10. So my answer will be what? 10 cos x. That's the answer. So if I look at this, if there are similarities, or rather they are common, so I would have my final answer will be minus 5x squared cos x minus 20x sine x plus 10 cos x. So you can actually write them down to see how these things came about. But if you've been solving consistently, you should be very, very fast because you're writing UTME. We are also asked to differentiate for number 27. So if you consider the question, we are asked to differentiate with respect to x. Now, if you look at it, the relationship between the two functions is division. So you can no longer use product rule, because in the previous one, the relationship was product. That's why we use product rule. So when the relationship is division, you're going to be using quotient rule. So what's the quotient rule formula? It is given by dy dx will give us v du dx minus u dv dx all over v squared. So in our question is y equals to 2x cos x. So this is our u, 2x is our u, then our v is cos x. So if 2x is our u, then du dx should give us 2. How do I know it's 2? I know the power here is 1. If I say 1 times 2 is 2, then deduct 1 from the power, that will give me 1 minus 1, 0. X raised by 0 is 1. 1 times 2 will still give me 2. So the derivative of cos x is what? Minus sine x. So let's throw everything into the formula. We're going to have dy dx will give me cos x. Du dx is 2. This value that I have here, I can put it at the back here like this, but it's not appropriate. So I have to put it at the front. So I have 2 cos x, then minus, what's our u? Our u is 2x. I have 2x. Our dv dx. dv dx is minus sine x. So since there's a minus sign, I can just multiply it here to put it here plus, then leave my sign here. So I would have that v du dx minus u dv dx. So the minus times minus multiplied to give us this all over v. What's our v? Cos x, but it's carrying square, so you're going to have cos square x. Now we can go ahead to simplify this to the simplest term, because this might not be in our options during our exams. So we would have 2 cos x over cos square x. That is, when you split the denominator to the two of them, you have cos square x. So we have to see where this leads us to. So I know that cos x here can cancel one of these. So we'll have 2 over cos x on this part. Then I know plus, this is 2x. I can rewrite this to give me sine x over cos x. Then I have 1 over cos x, or rather, I can put it like this, over cos x here, because this is cos square x. Cos x times cos x is cos square x, and I splitted it. Why I did that is because I thought it wise that if I write sine over cos, is the same as saying tan. So I would have 2 over cos x plus 2x over cos x. Then sine over cos is tan. Then I'll have tan x up here. So we are getting to the final destination. So I also know that 1 over cos x is sec x. Sec x is 1 over cos x. So these two that I have 2 over cos x. I can write it as what? 2 sec x. So this here can give me 2 sec x plus this cos x. There's another 1 over cos x here. So I can write it as 2x sec x tan x as our final answer of the derivative. 2 sec x plus 2x sec x tan x. We can still factorize though. If we factorize, we have 2 sec x into 1 plus x tan x as our final answer. If 202 base y equals to 100 base 10, find the value of y. So for this question, this is in base y, this is in base 10. All we could basically do is convert this to base 10 as well. So we would have 2 times y, 0 times y plus 2 times y is equals to 100. So number on the base, you have 0, 1, 2. So this will give us what? 2y squared plus y raised to the power of 1 is y. Then y times this particular 0 is 0. So we can throw that away. Y raised to the power 0 is 1. 1 times 2 give us what? 2 equals to what? 100. Then we'll have 2y squared equals to 100 minus 2. Then 2y squared should give us 98. So what we'll do next is divide both sides by 2. Divide both sides by 2. 2 cancels 2. Y squared should give us 2 in 98. 2 in 9 is 4. Take the 1 to 8. 2 in 18 is 9. Then when we square both sides, y should give us 7. So 202 there is base 7. In number 29, we are asked to find the mean of the values, this that we have here. So just find the average. We would have 6k plus 2k minus 5 plus k over 3 plus 1 minus 11k. Then 1, 2, 3, 4. There are 4 of them there. So we need to just sum them together and just break it down to the last. So we would have, collect like terms first. 6k plus 6k, that will give us 8k. 8k minus 11k, that will give us minus 3k. So I have minus 3k minus 5 plus 1, that's going to give me minus 4, but I still have not added k over 3. Then I have minus 4 all over 4. So what we did was 6k plus 2k is 8k. 8k minus 11k will give us minus 3k. Then k over 3 is still here. Minus 5 plus 1 is minus 4. So we need to simplify the numerator. So simplifying the numerator, would have an LCM, which is 3, of course, because the denominator here is 3. So 1 in 3, there's an over 1 here, there's an over 1 here. 1 in 3 give us 3. 3 times this will give us minus 9k plus k. Then 1 in 3 give us 3. 3 times 4 is minus 12. So if we flip that over, we would have minus 9 plus k. Minus 9k plus k will give us minus 8k. We have minus 8k minus 12 over 3 divided by 3. So if I change it to multiplication, it will become 1 over 3. So we would have minus 8k minus 12 all over 9 as the mean of these particular values. We have this last question for this particular video. We are told that a feather is tossed once, and we are asked to calculate the probability of obtaining neither a 3 nor a 5. So the possible outcome of a feather when it is being thrown or tossed is 6, because that's 6 faces. So if we don't toss a 3 or a 5, definitely the outcome can either be 1, can be 2, can be 4, or even 6. So formula for probability is number of possible outcome over number of required outcome. So probability of neither a 3 nor 5, number of possible outcome, since we are not tossing 3 or 5, the number of possible outcome will be reduced to 4. Then the total required is what? 6. So if we divide this, our answer is what? 2 over 3 as the probability of tossing neither a 3 nor a 5. So we have come to the end of this particular video. Endeavor to subscribe to this channel and as well like this video if you really learned something in this particular video. See you in the next session.